Hello, in this video we will learn about AWS IoT Device Tester, or known as IDT. IDT is a test automation tool that was launched in November 2018. IDT can test different products, but in this video we will learn about IDT for Amazon FreeRTOS. But many concepts that we learn here is useful for running IDT for any other product such as Greengrass. In this video we will start with a short introduction to some concept that you need to learn before running IDT. After that, we quickly jump into our demo, which is downloading IDT, configuring it, running IDT, and looking at the test result and report. At the end, we will also go through some troubleshooting guides for commonly known issues. As a reminder, in this video, I will go back and forth between this presentation and some other materials because I want to give you reference to as many online materials as I can that will help you to learn more about IDT and FreeRTOS. For a basic overview, IDT was created for APN partners to qualify their hardwares, and FreeRTOS is an operating system for microcontrollers. The device qualification program, as it is mentioned in their website, is a joint effort between AWS IoT and APN partner to qualify their hardware, so customers can shop with confidence and buy devices that they know will work with AWS IoT. Then what is IDT? IDT, as it is mentioned in their website, is a test automation tool for microcontrollers. So the qualification program will use IDT to test devices and qualify them for AWS IoT. Then you may ask, why do I need to get my device qualified? Because if you do, you will get listed in AWS Partner Device Catalog. For example, if a customer needs a device for FreeRTOS, they can see the devices that are already qualified for FreeRTOS, and they can shop with confidence. This is a great marketing for you. You make your code changes locally in your own lab and test it in your own lab. After you have a successful execution, you share that report with AWS and then you will get qualified. Other benefits that IDT provides is parallel execution. If running the tests sequentially will take 70 minutes, you can use IDT with 7 devices to cut that execution time to 10 minutes. IDT will run the tests in parallel between all those 7 devices and aggregate the result at the end and cut the execution time. This is very important if you want to run IDT for every code change. IDT is a test automation tool. Each test needs some configuration and resources to be able to run. Creating those resources and configuration is not always straightforward, and it can be very frustrating. IDT will take care of that for you. IDT provides better logging and reporting. That's very important to debug your code and find any issue. The content that we are going to cover in this video is going to be downloading IDT and going through the folder structure. You will learn about each folder and where you need to change. We also learn about device feature and why they are important. We will learn about user data and any configuration which is in it. We will learn about build and flash tool and commands and the best practice to provide those to IDT. We also learn about different commands within IDT and different ways to run the test. We will also look at the test result and logs. And at the end, we will go through some troubleshooting guides for some commonly known issues. We also learn about what is next and the features that are coming. From here, we will go to our demo and we will start by downloading IDT. So here we're going to start by cloning the FreeRTOS code. One thing that you have to make sure is that if you want to be qualified for any release of FreeRTOS, you have to get the tagged commit for that release. One way is to download it from here, or if you already have it cloned, as I have it, I'm going to look at my branches. So if I'm in the master branch, if I look at log, currently the head is here, but I will not be able to qualify against that. It should be a tagged commit. For that, I have to, if I want to be qualified for this version of FreeRTOS, I have to use this commit able to run IDT. So I'm going to check out that commit, and I'm going to check it out as new branch. I can name it 1.4.6, and here I am. So now I can be qualified for version 1.4.6. So if I look at the logs, my head should be the tagged version. That's very important, and that's the first step. Now I have the FreeRTOS code. The next step is to download IDT. Here in IDT, I see the latest version is IDT, which is for version 1.4.4. It is very important that for any FreeRTOS version that you want to be qualified, you have to download the corresponding IDT version. I'm on Mac, so I'm going to download Mac, but the instruction is going to be the same between all three operating systems. If there is any difference, I will make sure to mention that. At the same time, I'm going to check out version 1.4.4, and here I am all set. So the first thing that I want to see is opening this folder in my downloads. So this is what I just downloaded, and this is the version that I just downloaded. The very first thing that you want to do is to address the issue in Windows. The path to any file cannot be more than 260 characters. So one way to address this issue is always rename this to something shorter, IDT. And if you're in Windows, just put it under C folder. So it should be C IDT and then anything in it. So it will make the path shorter and it will address that issue. After you have FreeRTOS IDT, these are the folders that you will see. The bin has the executable file or binary file, and config file is the only place that you have to change. Anything in the config files is what you need to change. And after you run the test, you will see the results in result folder. Currently, we don't have anything, so we start with config file. The very first thing that you want to change is config.json. The only thing that you need to change here is the authentication method for AWS account. So you have to modify your AWS region to anything that you want. For me, US West 2 is okay. And authentication method environment means your secret and access key should be in environment variables. For me, because I already have CLI configured, and to make sure, you can always say AWS configure. And if you already have this configuration, means you already have AWS CLI. So for me, because I have this, I can always change this from environment to file, and that is what I usually prefer. It just uses the configuration that I have on file. And that is the only change that I have to do in config file. Next is device.json. This is an important file that you have to change. We will start by introducing the concept of pool. What pool means? Pool means a set of devices that support the same features. So if I have multiple devices that have the same features, I will put it in a pool. Now I can run IDT against that pool. So IDT can run the test in parallel inside the pools. And because every device in the same pool has the same feature, meaning that IDT can use all of them as they are identical devices and then aggregate the result from it. The first thing that I have to put here is a pool ID. The device that I'm using today is Espressif, so I'm going to name it Espressif devices. This information that you put here will go to your final report, so make sure you put correct information. I can put RMSQ. You can put anything. It's not really used by IDT, it's just for reporting. And here, features. Features is very important to get it right because IDT has many test groups that test different features in your device. And for example, if your device does not support OTA, IDT should not run OTA test group against your device. But IDT does not know anything about your device. So here is where you introduce your device to IDT. My device supports Wi-Fi, so I will say Wi-Fi yes. My device also supports OTA, so I can say yes to that. Not all devices support OTA, it's up to you. My device has TCP on chip. Some devices have offloaded and some devices do not have it. You have to configure that. And my TLS on my device is on chip. It can also be offloaded or no, depending on your device. And that is all I have to configure for my device pool. Now I have to put the devices inside this pool which have this feature. One thing that kind of is confusing for embedded developers is the JSON in general. If you are not familiar with JSON, make sure you read a little bit about it. To check the structure of JSON, you can always use online websites to check the structure of your JSON file. And also, if there is anything missing in your file, for example, a column or something, IDT will warn you about that. Also, having a nice IDE like this is good to tell you missing a comma or something. Now, the device ID, you can call it anything. It just needs to be unique. So I'm calling it Espressive1 and the port. The port in Windows is COM ports, COM1, COM2, COM3. In Linux, it is dev/tty and then followed by something. For me, these are the ports that I have. If you just type this, and you will be able to see all the ports that you have. This is the port that my device is connected to. So it is dev/cu/USB serial. So I'm going to put that information in my configuration file. And this is the port that my device is connected to. Serial number, for some devices, you have to provide the serial number. For example, for ST, that is how Flash uh, tool can find the right device if you have multiple devices connected. For Espressif, it does not matter because it just uses the port, and I already provided the port. And that is all I have to do for device. The next configuration that I want to do is for user data. As you can see, we have user data and user data parallel. If you have multiple devices and you want to run the test in parallel, you may want to use this one. Let's see what is the difference between them. As you can see, the only difference between them is this source path, and that is what tells the IDT to run the test in parallel or no. In my case, even if I have one device, I prefer to use user data parallel because if you use this configuration, it will work for one device or multiple device. But if you use this one, it will use for one device only. So it's always better to start with this one, and if you have more devices, you can just use the same user data. The first thing you want to provide here is source path. Source path corresponds to FreeRTOS path wherever you have it. And it has to be an absolute path. Um, this is the path to my FreeRTOS source code. If you are in Windows, again, it's going to be C/ wherever you save it. The second concept is build tool. This is the way IDT can build the code. You provided the code, now you have to provide the build tool. And because build tools are different between different devices, IDT does not know it in advance. You can provide the build commands directly here because as you can see, this means an array. So you can have it an array of commands here. But the way that's recommended is to write your build tool in a shell script, or if you are in Windows in a batch script, and just provide the path to that file. For example, I already have my build and flash um, file. So in the config file, I will put two of new files, build and flash. The build, this is shell script. If you are in Windows, it's going to be a batch file. If I open this one, we will see it has two commands. I could put these two commands directly here, but it is a better way to have it in a separate file and just provide the path for that. Now all I have to do is I have to provide the path to this file. So the build command can find it. Now I'm going to, the path to my file is here. This is where we saved in a download file and we called it IDT and the shell. Make sure there is only one space here. If you put two, it's not gonna work. So one space and the source path. Why? Because my build command needs the source path as a parameter. If you are running it in parallel, the path to your source file will not be this because we do not want to modify the file. So IDT will copy this to a new location and this new location will be this. This corresponds to new location. So my build command needs that source, so I'm going to uh, provide it as a parameter, and then after I have this path to the source, then this is the static path. And I'm going to follow the same for Flash. If I look at my Flash commands for Expressive, I need two. One, the path to the source of FreeRTOS, and I also need the port number. So here I will provide two parameter for the Flash. One is the source path and the other one, this source path corresponds to the source path. And then serial port, device connectivity serial port is from the device.json that we just configured here. If you remember, we just created this, and so device connectivity and then serial port. It will provide that port to this flash command. If you are in ST again, ST needs serial number. So instead of serial port, it will be serial number. And then you can also provide this tool so customers will be able to see the tools that you use to build so they can make sure to use the right one. I'm using make for build and it doesn't have a version, so I'm going to say version 1 and I'm using Expressive tool for flashing and I'm going to call it uh, version 1. The next thing is Wi-Fi. The client Wi-Fi is the credential for the Wi-Fi that IDT will use to talk to AWS. IDT needs to create resources in AWS account on behalf of you. You already provided AWS configuration in the config file, so it just needs internet to do that. So you will provide your Wi-Fi SSID and your Wi-Fi password. And what security type you use, I'm using WPA2. The next thing is test Wi-Fi config. This is required for the Wi-Fi test. If you already said yes to Wi-Fi, if your board does not support Wi-Fi, you do not need to provide this. But if you already said yes to Wi-Fi, you have to provide this information. And the test needs to disconnect from this Wi-Fi and connect to this Wi-Fi. It is a part of the test, so you need to provide a second Wi-Fi. So it's going to be second SSID for me. This should be a valid SSID and password. It depends on your network, so make sure you provide the right SSID and password. And my Wi-Fi is using WPA2. The next thing is if you already said yes to OTA, if your if your board supports OTA, you have to provide this information. Otherwise, you do not need this. Since my board supports that, I have to provide the firmware file path. Again, it depending on your board, this path can be different. I already have the configuration for this, so I'm just going to copy and paste it and then we can go over it. So the configuration that I have for OTA is this. The firmware file path will be the source path, as mentioned here, and then the path to where it is, and then the firmware file name for me is AWS test. Again, if you are using TI, you have to use the TI signer platform. For any other board, you will use the FreeRTOS default one, and then 2ARN for a signer certificate. I will show you how to create this too. If you do not have them and you do not know how to create them, if your board supports OTA, you have to come to Amazon FreeRTOS over-the-air updates in this URL. And if you look at the prerequisite, you have to follow these steps. But creating the code signer certificate is the only one that you need when you use IDT. So here, there is a step-by-step description depending on your board how to create that. So if you follow these steps, at the end you will have two ARN, one for secure and one for trusted and one for untrusted. So you have to provide those ARN here. And also this file is after you follow that steps, you will get this file, and that is all you have to do for user data. So basically user data has the built flash tool where your source path is and your Wi-Fi credentials and OTA configuration. And that is all. That is all we have to do for configuration. I'm going to save this files, and that's pretty much it. We configured IDT. Now the next thing we want to do is run a test. There are multiple ways to run the test. We start with very basic one device, as we only have one device currently. So we'll go to that file. So I saved it under download, IDT, and you go to the bin folder. Here where's the binary or executable file is. So I'm going to execute that binary. The first thing I will do is I'll do help. So it basically tells me the commands that I can run, which is list groups, list suites, run suite and version. You may want to start with version to make sure that you have the right version. So I have this version of IDT, which will work with 1.4.4. And because I'm already in version 1.4.4, I am good to go. As you can see, I'm in this version, so I'm good. The next thing I want to do is run a suite. So I will say run suite. And as you remember, we had two user data, so you have to say which user data you chose. I chose to use user data parallel, and that's it. Now I'm able to run a test, and that's all I have to do. So I'm going to test this run. It's running this suite against this pool, the only pool that we have. And because I have only one device, it's going to run it sequentially. Based on the information that I provided, uh, I said yes to TCP, Wi-Fi, OTA, and TLS. So it's going to run this test groups, full Wi-Fi, full OTA, and full TLS and PKCS11 on my device. This test will take about an hour if you are running it one device only. So I'm going to pause this device and see a successful result from my previous run, and we can see what happens when the run finishes. So I'm going to pause this, and coming back to the result folder. Once you go to your result folder, we already configured, so we go to result folder, and here we will see the result. I'm going to paste a successful run that I had before. If you open a successful run, this is how it will look like. The first one, AFQP report, will just tell you what test cases was able to run. It is 182 test cases. I did not have any failure. But the one that you want to share it with AWS to get qualified is this one, AWS IoT Device Tester Report. If you look at this one, this report is already signed. So if you modify anything in this report, it invalidates your qualification. Here I can see that I want to qualify for FreeRTOS version 1.4.4, and this is the information that I already provided, the pool and SKU. These are the features that my device support, and these are the tools that I used. I run all the tests, no failure. It took about 3,600 seconds, which is about an hour. In some boards, it may take longer. Again, it depends on your board, and all the test groups that was successful are here. If there is any failure, you will see some failure here, and you will see the message that will tell you what the failure was. If there was any failure, then you have to, let's say, if there was any failure in full secure socket. I will see the failure message in here. Then here, as you can see, there are log files corresponding to each test group. If I had any failure for a secure socket, I would come to secure socket and I could see all the log files. As you can see, copying the source code, running the build, starting the build, and after the build finishes, it starts to flash and finally it starts the actual test. And if anything failed here, you would be able to see the failure message. These are the output from the device, and finally generating report and cleaning the test resources. And you can see nothing failed. If there was any failure, you could see it here and you could debug it. And that is how you can debug anything. So again, you will come to the result folder. You will go to that run, wherever that run is, and you can see the execution ID here. So the execution ID will tell you which result folder to look for. And once you find that result folder, you can open it. And these are the reports and these are the log files for that single test run. That was pretty much it. So we successfully configured IDT and we did a successful run for one device. The next one, multiple device. If you are using IDT, you probably want to have multiple device. Why? Because if the test for one device took 1 hour, if I run the same test in 4 different devices, it will be 60 minutes divided by 4, 15 minutes. And if I have 6 devices, it's going to be just 10 minutes. And if you want to use IDT in your deployment process to test your code changes every time, you don't want to wait for 1 hour. So it is better to have multiple devices. And the way to do it is you basically connect multiple devices to your machine. And after you have those devices connected, you have to introduce them to IDT. You can come to device. And here, let's say I connected one more device. As you can see, the devices is an array of device. So all I have to do is I will copy this device and separate them by comma and paste it. Now I have 2 devices. I will call the second one Espressif2. And this one may be connected to another port. So that's pretty much it. Now I have 2 devices in my pool and both devices support all these features. Here, running the same command. Yes, so now I can see that if I make this one a little bigger, at the moment, Espressif1 is running full secure socket and Espressif2 is running full PKCS crypto operation. So as you can see, Espressif1 and 2 are being used in parallel. So 2 tests are running at the same time. And after the tests are done, IDT will get the result from both of them, aggregate them, and it will look like it was a single device because those devices are identical. So with this configuration, my test execution time will be half comparing to what it was before. So I'm going to just stop this one too. So you learn it is so easy to have multiple devices uh, for IDT. Now the second one is if you have multiple pools. And why would you have multiple pools? Because you may have different devices that are not identical. Let's say I am a manufacturer that I have 2 different devices that do not support the same features. I cannot put them in the same pool because all the devices in one pool should be identical. In this situation, I'll create a new pool. So I can simply copy and paste this one because as you can see, this is an array of pools. I'll copy this one and I will just paste it down here. So now I have two pools. I will call this expressive pool 2. So now I have two pools, and this one may not support OTA. For example, I will say no to OTA. So my devices in this pool are not going to support OTA, and I still have two devices. This can be like different ports. Let's say I call them like different ports, and they do not support OTA. So let's say what happens if I try to run this. So coming back here, same command is not going to work. Why? Because now it says before you had one pool, now you have two pools, so you have to tell me what pool ID to use. So all I have to do is I have to say pool ID, and I named it expressive pool 2. And if I run this, as you can see, it, it did not choose OTA because I said no to OTA. My device does not support OTA, so it should not test my device for OTA. And this test, because it has two devices, it is fast, but if I had four devices, it would be much faster. So I'm going to stop this test again, and we learned how easy it is to have multiple pools. The next one is single group. Before, we always run the whole suite, means the whole test. But if you are in the development phase, you may not need to run the whole suite. You just want to run one group for that feature that you are developing right now. For example, if you are working on Wi-Fi right now on your device, you just want to make sure the Wi-Fi is working. So how to do that? First of all, I have to find out what test group is corresponding for Wi-Fi. So I can say list groups. Now I can say these are all the test groups available to run. Let's say I just want Wi-Fi, so all I want is to run Wi-Fi. So I will use the same command as before, but I will just add one more parameter to it, which is group ID. So here I'm saying that do not run the whole suite, just run this group ID. So if I run this, as you can see, it is running only one test group, which is full Wi-Fi. But before that, it has to check the FreeRTOS version. That's what it always did. But after that, it runs full Wi-Fi only. And this test will take a few minutes to finish. This is how you test IDT for one test group only for a specific feature. So up to here, we learned how to download IDT, we learned how to configure it, and we learned how to run it. But up to here, everything was happy case. No problem, no failure. But let's come to troubleshooting. What if something is wrong? The very first thing that can happen and can go wrong all the time is if you provide wrong certificate or user data. Meaning that if you are here, if you provide anything wrong in the device, for example, if the structure of your JSON is wrong. As you can see, I have a nice IDE to tell me that something is wrong, but not everybody has it, so you may basically miss a comma. If that is the case, what happened is, if I run this same command here, it will tell me that in your file, in line 4, there is a wrong character in this file. So make sure to pay attention to the error that you will get from IDT. So if I come here to line 4, I will see, yes, I am missing uh, a comma before that, so I'm going to fix this. That is one problem that can happen. The other one is if you provide the wrong path. Let's say if I provide the wrong path here, this path does not exist, or I will call it wrong. If I save this, If I try to run this, it will say the source path you provided is not valid. So make sure you pay attention to the messages that you will get from IDT. So if I change this, it will be fine. The other problem that can happen is providing the wrong user Wi-Fi credentials. If you do that, your test will fail. It will start running, but at some point it will fail because your device will not be able to connect. And also, if you say yes to OTA, as I said in this pool, I said I have OTA. If you did wrong, if you did something wrong, making this certificate, or let's say I changed something in the certificate and this is not correct anymore, uh, this will also cause a failure if you are running it for OTA. Yes. Now it's going to run OTA, but my certificate is wrong, so we will see what happens. Yes. So it's telling me that in your user data in OTA configuration, these two certificates are not valid. Something is wrong with them. So I have to change that again. If I provide the right one, it should be fine. So these are the things that can go wrong if you provided the wrong certificate, or let's say Wi-Fi SSID is required, but you do not provide that. What happens is I'm trying to run it. It will tell me that you have to provide the client Wi-Fi config. Otherwise, we cannot run the test. So I will save this. So these are the problems that can happen when you're configuring your test. The other one is the device port. As we said before, Windows uses COM. It will be COM1, COM2, COM3, whatever. Mac, it will be in this path. If you type def cu dot and then press tab, it will show you all the serial port that you have. And in Linux is usually in this path. So make sure you provide the right port. Otherwise, IDT will not be able to communicate with your device. The second thing that can happen is build and flash tools. If your commands are not right, or you don't provide the right path to those commands, or you fail to pass the parameters that your build or flash tool needs, as I have to pass these two parameters. Again, in ST, you have to provide the serial number as well. If you fail to provide those information, it may fail. The logs, people have problem finding logs. Again, the logs are under the test run result. So if you go to the result folder and then the execution ID is printed when you run the test, you can find the logs here. So you can look at the logs and see what's going on. And anything that's printed in the screen will be also logged here in Test Manager. So anything that was printed in the screen, I can see it here. If you remember this error when we were running it, I can see it here as well. The other thing that can happen is uh, Windows path issue. As I said before, Windows path cannot be longer 260 characters. So to fix that problem, as I suggested before, make this name as short as you can. For example, I named it IDT. I renamed the file that I downloaded. I made it the IDT and save it under C file or the wherever in a shorter path, so you will not face that issue. Forward slash versus backslash. As you may know, in Mac and Linux, we use forward slash, but in Windows, we use backslash. But you cannot use backslash in JSON file. So in any configuration which is JSON, you always have to use forward slash. So here, do not use backslash because you will see this error. So always use forward slash in JSON files, but in your build and flash command, as we can see in the config file, if I have builds, so first of all, in Windows, it will be build slash BAT for batch file, and this path will be backslash. So this is what you have to do when you are on Windows. If I want to do the same thing on Windows, I have to change all these paths to backslash, and this will solve my problem. So that's another thing that you have to consider. And that's pretty much it. These are the common problems that we see when we are running IDT. So up to here, again to recap, we learned how to download, we learned how to configure FreeRTOS to use the tagged commit uh, for corresponding version that we want to use. And we learned how to run the test for single device, for multiple device, for one pool, for multiple pool, or for one group only. We also learned how to troubleshoot some common problems and some issues that we will face. What is next? IDT team is working to improve the current features, and also they are adding a lot more features. I'm not able to talk about all of those, but the next version of IDT will be much more user friendlier, and it will have much more features that you asked for. Very short talk about device tester for AWS IoT Greengrass. If you already know how to run it for FreeRTOS, you probably know how to run it for Greengrass as well. There are only a few differences between running IDT for Greengrass and FreeRTOS. I'm going to talk about those one. First of all, Greengrass does not have user data because in user data, we provided build and flash tool and source code. These are the things that Greengrass does not need, so there is no user data for running IDT for Greengrass. The second thing is product folder. So for Greengrass, there is no source code, it's the binary. So you have to provide this binary by putting it in the product folder or providing the location. That means if I have a Greengrass IDT, let's see if I have it. Yes, I do. Here under product folder, in GGC, you have to download Greengrass from AWS console and put it under GGC. But if you already have Greengrass installed in your device, all you have to do is in the device.json, you have to provide the path to that Greengrass. It's installed in your device, you have to provide that location for Greengrass. So either put it in the product folder, or if it's already installed in your device, provide the location for that. The other difference is device connectivity. As we saw in FreeRTOS, the connectivity of the device was UART, means serial port. In FreeRTOS, however, the connection is mostly uh, SSH over IP. So it will be SSH connection and the IP address, and you have to provide how to log in to that device, meaning the username and keep private key path. And that's pretty much it. These are the only differences between running AWS IoT, a device tester for AFR or FreeRTOS versus Greengrass. And I'll make sure to provide a video for running IDT for Greengrass as well. You can check the description for that link. If you have any question, I suggest to go to FreeRTOS forum where you can find a lot of questions that people already ask and you can ask your question as well. If you have AWS support, uh, you can always, if you face any problem, I recommend to go to your IDT and remove any sensitive information that you have. For example, in your user data, you can remove Wi-Fi username and password and some information that you provided here that you don't want to share. You can remove this, and after that, I suggest to zip this folder, compress it or zip it, and send the whole folder to AWS because then they will have access to your configuration, they will see the test result, and they will have all the logs so they can help you better. Technical documentation is also a good way to get familiar with more concepts, if you come to the download page, in the top of the download page, you will see a link to technical documentation. If I open this page, anything that we talked about today is basically documented here. So if you forget anything or you need more details, everything that we talked about today is also available in this documentation. And also you can leave comments or suggestion about this video. If there is anything that you wanted me to cover but I did not, you can comment below and I will make sure to address those problems either as a reply or making another video for you. And that was pretty much it. Thank you so much for watching and I hope it helps you to run IDT and get qualified.